Shh. All right. So the first thing that I want to take note of is the fact that it says the sum. So if I see the word sum, what does that mean? To add, right? So it means that we're going to add. If we're talking about the sum, it means we're going to add. Now it's the sum of the medians. So if I'm looking over at my box and whisker plot, Kelvin, can you tell me what is the median for the New York Knicks? 80. Very good. We can find that by looking inside the box. The line that's inside of the box is going to represent our median. So for the New York Knicks, we have a median of 80. So I'm going to go ahead and write that down off to the side. That the median is going to be 80. Now what about for the New Jersey Nets? Diego? 79. Again, it's the box or the line inside of the box that's going to represent the median. So the median here is going to be 79. Now remember, if we scroll back over to our question, the question said, what is the sum of the medians? So we said sum meant we had to add them. So we're going to take both medians, the 80 and the 79, and we're going to add them together, and that's going to give us 159 for our answer. Now if we look at question number 2, or sorry, question number 1, part B, now it's asking for the difference of the interquartile ranges for the teams. So what does difference mean again, guys? Correct. So we're going to subtract. Now, interquartile range. Who can raise their hand and remind us, how do we identify the interquartile range in a box plot? Santiago?
It's like the left side of the box and the right side.
Correct. So essentially it's just the size of the box. How big is the box? Starting from the left side of the box to the right side of the box. Basically subtracting your upper value of your box minus your lower value of your box. So go ahead right now, right up here, I want you to make a note that the interquartile range, and for now on I'm going to label it IQR, but you need to know that IQR represents interquartile. So the interquartile range is the size of the box. That's really important to remember. Your interquartile range is the size of your box. So if we're taking a look here, we need to identify the measurements for the Knicks and for the Nets based off the size of the box. So let's start with the Knicks. For the IQR, again, it's going to be from the lowest end to the upper end. What's our lower end value? 76. And what's our upper end value? 81. So we're going to take 81 and we're going to subtract 76, and that's going to give us an IQR of 5 for the Knicks. Now we're going to do the same thing for the Nets. What's the lower value for the Nets? The lower quartile? 75. What's the upper quartile? 82. So now we're going to take 82 and we're going to subtract 75, and that's going to give us 7. Okay, so there's our two IQRs. Now refer back to the question. What did the question ask us to find? The difference, right? Not just find the IQRs, but find the difference of those IQRs, of the interquartile ranges. So what's the difference between the two IQRs? You have to subtract them, which is what? 2. Okay, so over here off to the side, we're going to go ahead and put that 7 minus 5, which is equal to 2. And I will say that quite a bit of your test is going to be based off of doing things like this. There's a first quartile and a third quartile. So to find the IQR, you're just taking the difference between the two quartiles.
Would it ask you to just do like, what about what if it's like take out critical and James? Would you just subtract 76 and 81?
Yeah, if it just wanted to know, hey, what's the interquartile range of the mix, you would just say 5. Yeah, but this case it wanted the difference between the two different interquartile ranges. Okay? All right, let's take a look at problem number 2. Problem number 2, it says the dot plot, so this dot plot right here, is going to show the number of minutes 2 students spent practicing the piano. Question A, which student has a larger mean and by how much? So now here's a really important thing that I want you to make note of. For looking at the dot plots, there's a really neat characteristic to the dot plot here, actually to both dot plots. What kind of characteristic do you think you see here?
It's symmetrical.
Very close. Symmetrical. It's symmetrical. Symmetrical. I like that. We'll go with that one instead. Up at the top of your paper, I want you to write the following statement down. If a dot plot or box plot, remember box plot's another way, ooh, block. Box plot. If a dot plot or a box plot is symmetrical, meaning that if you were to cut it in half, it would be mirror images on both left and right side. So if it is symmetric, then the mean and median are identical. Uh-huh. Then the mean and so that's really important for you guys to make sure that you remember. Shh. If a dot plot and a box plot is symmetric with the way that it looks, it's symmetric, meaning the left half is mirror image to the right half, then it's going to be identical mean and medians. So, for example, here, if we're looking, this is our dead center. The left half mirror images the right half. Same thing here. The left half is going to mirror image this right half. If we were to go down to this box plot, are either one of these symmetric? The bottom one. Okay? If you zoom in, the bottom one is symmetric. If you look, the left side of the box is a measurement of 10. The right side of the box is a measurement of 10. The left side of the range, so from 20 to 50, that's a measurement of 30. The right side is also a measurement of 30. From 50 to 80, it's a measurement of 30. So it's mirror imaged. It is equal size on the left as it is equal sized on the right. But the corner creamery, this one is not symmetric, right? In fact, the lower half, the left side of the data set, is stretched out further than the right half is. What this tells me, and I want you to pay very close attention to what I'm about to say instead of turning around and talking to each other. So what this says, when your lower half is farther stretched than your upper half, then that means your mean, your average, is actually lower than your median. Let me say it again. In a box plot, or even in a dot plot, if the lower half of your data set is longer stretch, is a larger stretch, see how it's stretched out further than this side is? If the lower half is a longer stretch than the upper half, then that means your mean, your average, is lower than your median value. And then vice versa. If your upper half happened to be more stretched out than your lower half, then your mean would be greater than the median. Okay? So where it falls heavy, if it falls heavier on the left side, then the mean is lower than the median. If it falls heavier on the right side, then the mean is higher than the median. If it's equal split, then they're identical. You guys got it? All right. So let's go back again to number 2. We want to know which student has a larger mean and by how much. So again, we already stated that these two data sets are equal to each other, or symmetric. They're both symmetric. So that means all I have to do really is find the median. So who can tell me for Lily's value, what is the mean going to be? Kelvin? 60. And what about for Alessandra's? What is her mean going to be then? Kyle? 50. Okay? So Lily's centered value is 60, so that means her mean is also going to be 60. Alessandra's centered value is 50, which means her mean is also going to be 50. Now, if you wanted to, you could actually sit there and write it all out and calculate it. Couldn't do that with a box plot, because the box plot only tells you the smallest, largest, and middle number. Okay? So it really doesn't give you the data set. But here, a dot plot does give you the data set. For Lily, her data set is 50, 55, 55, right? Because she's got 2 dots for the 55. Then it's 60, 60, 60, because she's got 3 dots for 60. Then it would be 65, 65, and then 70. So you could write out the data set and then find the mean and calculate it that way. It's just going to take you longer, and there's no need to do it if you know, hey, it's symmetric, mean and median are going to be identical. But if you were to add all these up and divide it by how many there were, which is 9, you would get 60. Okay? So who's got the larger mean? Lily. By how much? 10. Okay, so let's go ahead and write that down. Okay, and then for problem B, which student's mean is identical to the median? Both, right? Because they're both symmetric. We've already stated that before. It's both. Because they are symmetric data. Yeah. Lily's mean is larger than Alessandra's, right? And 60 minus 50 is going to give you 10. All right, let's take a look at number 3. Number 3, based off of the box plot, we want to know which store has a larger range of customers. Now remember, range doesn't have to do with the box, does it? It has to do with the whiskers. Okay, so the range is based off of the whiskers. So it starts with your smallest number and extends all the way to your largest number. Okay, so for the corner creamery, I'm going to just put CC. What's my largest number? 90. What's my smallest number? 25. So I'm going to do 90 minus 25. That's going to give me 65 for the corner creamery. Again, it started at 25 and it ended at 90. What about for Sue? What's her largest? 80, and her smallest? 20. Okay, so for Sue, we're going to do 80 minus 20, which is going to give us 60. Now the question's asking, which store has the larger range? So which store? CC, Corner Creamery. And if it asks by how much, you would just subtract and say, oh, it's larger by 5. Okay, for problem B, what is the interquartile range and the median for both stores? Okay, so let's start with CC. Again, the interquartile range is the size of the box. So CC starts the box at what? 45, and ends it at what? At 80. So you're going to take, for the IQR, you're going to take 80 minus 45, you'll get 35 for the IQR. Okay, what about the median for Corner Creamery? 70, very good. It's going to be 70. That's that centered value inside the box. Okay, let's go ahead and look at Sue. Her IQR, or her store's IQR, is going to be 40 to what? 40 to 60. What's that size? 20, right? 60 minus 40 is going to give you 20. So there's your IQR for Sue's store. And then what was the median for Sue? 50. Good. All right. What you guys are going to do is on the back side of this, you're going to work out those problems. Now I want you to be very careful because on the back, some of the questions have multiple answers that you're going to have to give. There's a total of 10 questions on the back. Even though there's only 4 questions given, there's a total of 10 that you're going to be responsible for. Let me flip it over real quick and then I'll turn it back in a second. For question number 4, there's only one answer, so I'm going to put 1 point. For question number 5, there's 1 point. Okay, question number 4 just wants the difference between the medians. Question number 5 just wants to know which animal has a larger mean. Question number 6 has 2 points. What car type has a smaller range? And then by how much? So that's actually worth 2 points. Question number 7 is worth 6 points. 6, you want the interquartile range for both fruits and vegetables, so that's 2. You want the range for both fruits and vegetables, that's another 2, so that makes 4. Then you want to know which food has a larger median, that's the 5th question. And then by how much, that's the 6th question. Make sure you have all of those parts labeled. Everybody clear? 1 point. All right, I'm going to turn this over so you guys can see what I just did here. You have 10 minutes. 10 minutes to get this done.